Our journey begins about 13.8 billion years ago, at the very beginning, with the Big Bang. Imagine nothingness, a void, a blank canvas, then suddenly an explosion of unimaginable magnitude and intensity. This was not an explosion in the conventional sense, happening in a pre-existing space. No, this was the birth of space and time itself, the moment everything began. The Big Bang theory, as it is known, is our best scientific explanation for the origin of the universe. It suggests that all the matter, energy, space, and time in the universe was once concentrated into an incredibly dense hot point, smaller than a single atom. Then, in a fraction of a second, it expanded exponentially, faster than the speed of light. In this fiery, chaotic maelstrom, the first particles were born. The universe was so hot and dense that particles and antiparticles spontaneously formed and annihilated each other. But for reasons we don't entirely understand yet, there was a slight imbalance. For every billion pairs of particles and antiparticles, there was one extra particle. As the universe expanded and cooled, these particles began to combine, forming the first atoms. The universe was a soup of hot plasma, full of protons, neutrons, and electrons. When it cooled enough, these particles combined into hydrogen and helium atoms, the simplest and lightest elements in the periodic table. This process, known as nucleosynthesis, took place in the first 3 minutes of the universe's existence. Yes, that's right, 3 minutes. It was a fast-paced start for our universe, to say the least. But it was just the beginning. These atoms would go on to form the stars, galaxies, and ultimately, everything we see around us today. The stage was set, the actors were ready, and so the cosmic drama began. This is the story of the birth of our universe. A story of creation, expansion, and the formation of the building blocks of everything that exists. It's a story that scientists are still exploring, unraveling, and marveling at, even after billions of years. As the universe cooled and expanded, gravity began to pull matter together into the first stars and galaxies. Let's delve into this fascinating process. The universe's first stars, known as population 3 stars, were not like the stars we see today. They were primarily composed of hydrogen and helium, the two lightest elements. These titans were much larger and hotter than today's stars, living fast and dying young in spectacular supernovae. These explosive deaths served a crucial purpose. The intense heat and pressure within these stars triggered nuclear reactions, forging heavier elements like carbon, oxygen, and iron. As these stars met their dramatic end, they scattered these newly formed elements throughout the universe, enriching the interstellar medium with the building blocks necessary for future star and galaxy formation. The next generation of stars, known as population 2 stars, were born from this enriched material. They were smaller, cooler, and lived longer than their predecessors. These stars clumped together, pulled by the relentless tug of gravity, forming the first galaxies. These galaxies were chaotic and irregular in their youth, but over billions of years, they evolved. Some became spiral galaxies, like our Milky Way, with stunning arms of stars spiraling out from a central bulge. Others became elliptical galaxies, their stars moving in random orbits like bees around a hive. Within these galaxies, stars continued to live and die, each generation enriching the cosmos with more and more heavy elements. This cycle of stellar birth and death, creation and destruction, is a cosmic dance choreographed by the laws of physics. It's a process that's still happening today, right now, as new stars are born from the ashes of their predecessors. They ignite, shine, and eventually meet their end, only to sow the seeds for future stars. These stellar nurseries and graveyards were the building blocks for what was to come next. As we journey through the vastness of the universe, let's take a brief pause. We've traveled from the birth of the universe, witnessed the formation of stars and galaxies, and there's still so much more to explore. If you're as captivated by this cosmic story as we are, don't forget to hit the like button and subscribe to our channel. Your support helps us continue creating content that takes us all on these incredible explorations of our universe. Remember, Every like, every comment, and every subscription helps us reach more people, spreading the awe and wonder of the cosmos. So, whether you're a longtime subscriber or new to our channel, thank you for being a part of this journey. Now let's buckle up and dive back into the cosmos, where we'll witness the emergence of planets and eventually, life itself. The story of our universe is far from over, so stay tuned as we continue our cosmic journey. Among the countless galaxies, stars, and planets, a special place emerged, our home, Earth. In the cosmic dance of celestial bodies, about 4.5 billion years ago, our solar system began to take shape. A giant molecular cloud in the Milky Way collapsed under the weight of its own gravity, giving birth to our Sun. Around this young, fiery star, a flat disk of dust and gas began to form, spinning and swirling in the vastness of space. Over millions of years, these particles started to clump together, growing into larger and larger bodies. Thus, the planets of our solar system, including our beloved Earth, were born. But Earth was not always the blue and green oasis we know today. Initially, it was a hot, molten sphere, bombarded by other space debris. Over time, its surface cooled down, and a thin crust formed. Water vapor, released from the planet's interior through volcanic activity, condensed and fell as rain, filling up the basins to form the oceans. In this primordial soup, the stage was set for the greatest magic trick the universe had ever performed, the creation of life. Around 4 billion years ago, the first life forms, simple single-celled organisms, made their debut. The exact process of how life emerged from non-living matter remains a mystery, a question that scientists are still trying to unravel. From these humble beginnings, life on Earth embarked on a long, complex journey of evolution. Single-celled organisms gave way to multicellular life. Fish emerged, followed by amphibians, then reptiles. The age of dinosaurs came and went, making way for small mammals. Among them, a particular species of primates evolved, with an uncanny ability to learn and adapt. That's us, humans. From stardust, life as we know it was born, a testament to the universe's incredible creativity. In the grand scheme of the cosmos, we're but a tiny speck, yet we're part of something immeasurably vast and beautiful. Every atom in our bodies was once a part of a star, a poetic reminder of our deep connection to the universe. With the past laid bare, what does the future hold for our universe? As we move forward, it's crucial to understand that our universe is not a static entity. It's in a constant state of change, continually evolving and expanding, much like the horizons of our knowledge. The future of our universe is a topic of much speculation and debate among scientists. There are several theories, each as fascinating as the next. One prevailing theory is that of an ever-expanding universe. According to this theory, the universe will continue to grow indefinitely, with galaxies becoming increasingly isolated as space stretches out between them. Over unimaginable periods, stars will exhaust their nuclear fuel, leaving behind white dwarfs, neutron stars, and black holes. Eventually, these too will decay, leaving the universe a dark, cold, and empty place. Contrary to this is the theory of the Big Crunch. This theory posits that the expansion of the universe could one day reverse. The universe might then start contracting, pulling everything back together into a singularity, a point of infinite density. This could potentially lead to another Big Bang, giving birth to a new universe, a new beginning. Then there's the concept of time. The arrow of time, as it's known, points from the past to the future, driven by the increase of entropy or disorder. But what if, as some physicists suggest, in the very distant future, as the universe expands and cools, the arrow of time could reverse? This is a mind-bending possibility that challenges our understanding of reality. These theories, while speculative, are grounded in our current understanding of physics. Yet, as we've learned time and again, the universe has a way of surprising us. As our knowledge grows, so too does the complexity and mystery of the cosmos. The universe's story is far from over, and we are fortunate to be a part of this grand cosmic tale.